Hello everyone, for First Updates Now, I'm Tyler Olds, and you're watching Behind the Bumpers. It's a fun show where we dive into FRC robots and what makes them work. And today I'm here with team number 4655, Stateline Robotics from Rockton, Illinois. 4655 is a team that I've mentioned several times as a future breakout team, as they've made the playoffs at every single regional they've attended since the 2015 season. And today I'm here with Zach, Amanda, and Abby, and we're going to be breaking down their 2021 robot, which is a modification of their 2020 bot, here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Zach, we're going to be starting out with you. You guys took your 2020 robot and modified it for 2021, and one of those modifications was on your intake. So we're going to be starting there and going all the way through your robot with different features, both for the 2020 and 2021 game. But tell me about the intake that you have here on your bot and what's been modified.
Yeah. So we started off by one of the big things we wanted to modify was actually making this intake, which is the current one on there, wider. So the old one was only about as wide as the belts on our robot.
Sure.
So it just a lot would bounce off the sides of the robot. So we made it a lot wider. As you can see, it's almost as wide as the entire robot. And we put on big mecham wheels, so that no matter where it hits, it will actually draw the balls into the center, and then they'll go into the robot.
So on there in particular, with the mechanisms, when you changed from 2020, how much more effective was this for you? Did you notice a considerable intake capability than what you had prior?
Yeah, so it's actually made a very big difference. Before, we would have a lot of balls that would just bounce off the sides. We had to be fairly accurate with, getting them onto the intake for them to go in. And because of the size of our intake, that wasn't actually much better than not having an intake at all. So this has been a huge improvement.
I'm glad to hear that, no doubt. And I know on your collector here, your hopper that you have, you've made a couple modifications, and I see a lot of polycord there as well too. So tell me a little bit more about that.
Yeah. So for our collector, our intake, or our
the hopper area, right?
Yeah, ball hopper. We have the poly belts because they do a real good job of moving the balls. They're very robust. They don't break often, but if they do, we can fix them very easily. We actually have these hose clamps here, so that when the balls go in, and this rotates around. Amanda, why don't you do that real quick? It grabs the balls from that dead zone down there and lifts them right up in.
And how many power cells are you able to hold? Did you modify it to only be 3 for the at-home challenges, or is this robot still holding 5?
Yeah, so we can actually hold 5. Obviously, we're only supposed to be holding 3. For this, it actually works better because that before was our storage and our way of moving the balls up and into the shooter. So now we kind of are able to hold one ball in the shooter, one ball on top of that, and then one ball in the ball elevator.
Sure, that makes a lot of sense on there. So I want to expand a little bit more on the polycord that you have on the bot, because it looks like you have the crosses in quite a few places. Has the polycord worked really well for you? Have you had it slip off at all as a belt? Or tell me a little bit more about your success or issues with that.
Yeah, actually, we've had a lot of success with the poly belt. We haven't, I don't think, have had any of it break. But in case it does, we have a lot of redundancy. So, there's a lot on each side, which we don't need that much, but it's good to have it. And then we have both sides run off of one motor. So we actually have X belts here, which change the direction from one side to the other. We actually have 4 of these X belts just in case any of them break. Then, it's still going to run. We're not dead in the water.
No, that's awesome to hear, and looks very efficient from what I can see. So we're going to be moving into the shooter now. So we're going to bring Amanda on for this, who's going to be talking about the shooter, how that operates, the camera that you have, because you switched over from a Limelight to something else. I'd love to hear more about that. And then even though it's not used for 2021, you do have a climbing robot, so love to feature that as well too, Amanda.
All right. So coming out of the hopper, the balls travel down a track that we have that is allowed to go up and down dependent on our shooter angle, so that the balls will travel perfectly down into the shooter box. And as you can see, we have 2 line sensors on our robot, one at the top that tells the shooter when there is a ball ready to be loaded, and that pulls the piston back, and a second line sensor at the bottom, the robot when there isn't a ball in there, so it pushes the piston back out. With the shooter, we have the program automated for this entirely, so that, or we have an option for it to be automated entirely for the autonomous, that it will send it in there and then it will know that it's there and then fire after it is aware that it has been loaded, and then it will just reload it again and then keep firing for the autonomous.
So you're saying he essentially knows not to fire too early, right? So can you dive a little bit more in particular? Like, what does that mean exactly? So like it just waits for a little bit, or is there another sensor that says, hey, the ball is settled? Can you tell me more about that?
So we've had problems before during the autonomous where it would fire the piston too soon, so the wheels would not be going at top speed, so it would not shoot as accurately as it can. So it would fire it once the ball is just not in the right position, but with all the sensors, it waits till it has settled onto the piston, of which we have a little cup on it, so the balls can better settle into it.
Sure, that makes sense.
Uniform to the balls. So having the line sensors there for all the autonomous code and everything, it knows that it has settled, and that means it's going to be a bit more accurate.
And then on the shooter itself, it looks like you can do some adjustments on that shooter in regards to the angle and pitch on it. So how many, is it completely adjustable? Do you have some set angles you use? Tell me a little bit more about that. And I'd love to then jump in a little bit more into what you've replaced the Limelight with.
Okay, so our shooter box has 4 presets for the separate places that we shoot from for the accuracy challenge. So we just press a button and the shooter box will go to a preset angle that we had already set up, and then we can fire from that and hopefully get as many shots in as possible. And then related to that, we previously, on our 2020 version of this robot, we had a Limelight here, and that gave us a few issues since it's so low on our robot and it's at such a shallow angle.
Mm-hmm.
That it had some trouble seeing the reflective tape that was on the power port. So this year we have changed it over to a Snake Eyes, which instead of just doing the reflective, it uses infrared light, which has given us a lot better luck with actually seeing the target.
And was that pretty much plug and play for you, or did you have to do any specific code and programming to it? Tell me a little bit about what that transition between the Limelight to the Snake Eyes was actually like.
Well, we kind of had to change the mount a little bit. I believe it just came with the camera, and they had to actually print the case that we have on here currently. So we had to get that all set up in order to actually be able to mount it on our robot, as well as it was at least reasonably in the same place as we had needed it to be for the Limelight previously, which is why it's so much better, because we didn't have to spend all the effort to find somewhere else where it actually would be able to work without getting in the way of a lot of other mechanisms on the robot.
What about from a code perspective, though? Was there anything you had that drastically changed in how you approached how you programmed your robot?
They had to, I believe, use a separate program for reading the information given from the camera to read where the actual shooter, the power port is.
Sure.
So they had to adjust that a bit and just tweak it a bit in order to be able to get different values and interpret the values differently.
Yeah, that makes sense. So I want to keep moving on to your climber. Now, once again, the climber not really used for 2021, but part of your 2020 robot. So we'd like to still show that off and feature it. Tell me a little bit about the climber and how it was used for the 2020 challenge.
So for our climber, we used a set of pistons and a set of shocks so that we have this also kind of automated we release a winch on this side of the robot. And as it is releasing, the shocks will push this set of bars up. And then once it gets to a certain point, the pistons will also fire and bring the whole system up. And all of this was in order to keep this within the frame perimeter.
Sure.
So we kind of had to set up the program to a very specific point of we couldn't open the pistons before these had gotten to a point that they wouldn't be outside of the perimeter to the front too far. But we had to make sure that the pistons fired before the top arms got too far out on the front of the robot or the back of the robot.
And that was all automated, though, right? Like you didn't have to have did your operator actually have to worry about that, or did you completely automate that process?
It's completely automated.
Okay.
We have one button to press to send everything out, and then another button to reel it in, and then we can pretty consistently get it on the very center of it.
Sure. So let's head back over to Zach, who's going to be talking a little bit about the swerve that's on your robot. And then we're going to wrap it up with Abby afterwards and talk about some of the judged awards, that sort of thing. But Zach, in particular with the swerve, I know talking to me ahead of time, you mentioned that you have some of the anti-mark modules. And one of the things you really want to comment on is just how easy it was to swap out when needed. So tell me just a little bit about your swerve and then some of that accessibility benefits that you've had as well.
Yeah. So this is the swerve drive module that we've gone with. It is the anti-mark swerve, although it is not the stock anti-mark swerve. We've made some changes to make it work better for us. So we've gone with Neos as the main motor, as they provide a lot faster movement. We've actually changed our main wheels to Coulson's because we found that they're a lot less prone to braking, as well as they get a lot better traction. So they make basically this robot unpushable unless there's another robot that's got a very good tank and they're very heavy. So that is giving us a very big advantage. One of the big things that, we wanted, and also we have since added absolute encoders as well.
Sure.
Our first year with this swerve modules, we had to, at the start of every single match, make sure that these were in the right alignment. Otherwise, we'd have big issues. In fact, we did have one match where we started where it was completely backwards. So one wheel was trying to drive backwards where the other three were trying to drive forwards, and the whole robot was fighting itself. With the absolute encoders, it always knows where it is without any human error.
Hey, Zach, let me ask you a quick question on that. You mentioned you went over to the Coulson wheels, and sometimes when I think of Coulson's and swerve, there can be a lot of torsion that comes out of that. So have you had any issues with like there being almost too much grip and, almost trying to rip out the modules themselves, or have you been able to secure those pretty well? Yeah,
so we actually did have some issues where the swerve drives were almost wanting to damage themselves. So what we have on our controller is a button where if we're doing something that we want to be real precise, the wheels will brake automatically, but or they'll stop automatically. But for most driving, we actually have our swerves set to go to a rolling stop,
Sure.
which counteracts that issue of there being too much friction.
Makes a lot of sense on there. All right. Anything else on the swerve you wanted to cover?
Yeah, so one of the big reasons why we love these Indy Mark swerves is if something does happen in a match, obviously these are pretty complex, so stuff does break. We have had it happen where something's broken that we can't fix on them in between matches, but it only takes us about 5 minutes because we have this set up where we can undo 6 bolts and literally drop this out, unplug the 3 wires that are plugged into it, put our backup ones in. We've got 4 backups, and then plug everything back in, and we're good to go. So that's saved us a couple times, where instead of having to rebuild an entire swerve drive, which can take an hour depending on what's wrong with it, we can just bolt in a new one, and we're good to go if we've got a match coming up.
Well, I think that's a pretty good endorsement for the Indy Mark swerve module. It's great to hear that it has been very successful for you, and I'm sure that is something that other teams want to hear about too, who maybe haven't had a chance to test it out. So I appreciate that. So we're going to wrap up here with Abby and talking about some of the submissions that you've done here in the 2021 season. And I know you do have a flyer we can show off as well too, and maybe talking about the video and maybe a couple other things as well too, Abby.
Yeah. So we spent a lot of time working on our submissions for the at-home challenges by taking videos of our autonomous and taking pictures of the robot. And we also spent a lot of time working on our flyer for our submissions. And for that, our mechanical students and along with our logistics students worked on this to make sure it was as accurate as possible.
So talking about, I come from the marketing world myself on things. So tell me a little bit about in regards to, creating this. What program did you use to create it? What were some of the things when you look at the copy that's on it, the actual text that's on it that you really wanted to highlight? What went into something like this?
I know that they used Microsoft Word to make sure that the borders and the graphics were good on it. And I believe that Zach worked with another one of our logistics members on the facts that are on it.
So I think something that really tells us that a lot of people look at something like this, they're like, wow, I have to know how to do InDesign and vector images and stuff like that. And this can be done on Word. You can really create something that looks really nice. I think in other years, this would be something you'd give the teams to tell people about your robot, right? And it's something that every team should be doing. And you can do it as something as simple as Word. So yeah, appreciate that. Well, 4655, thank you so much for taking the time to tell us about your robot and your team and everything that's been going on with the at-home challenges. Love to see the modification you did on your robot. I think it's super cool to be able to take something that you had. It still works for the Infinite Recharge Challenge if you ever do some sort of in-person play as well, and then works great for the at-home challenges. So I wish you best of luck. I hope we get a chance to see this robot in person in action sometime in the future. But till then, wish you best of luck throughout the rest of the season. Thanks, guys.
Thank you.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.